based on this pair of keys, I'm going to read the character. But while writing the character, I'm going to write the character as it is. If I consider the substitution cipher technique, each character is replaced by another character. Stream cipher, we are going to have encryption algorithm as well as decryption algorithm. When I perform XOR operation, I'm going to get the output 0. Hello to all, a warm welcome to my new session on traditional symmetric key cipher. I'm Revati from the Department of Computer Science, Vidhyaashram, First Grade College, Temple of Excellence, MYSURU. So dear student, before going to start my today's session, let me to recall the topics which I have discussed in my last session of this unit. There I started with what is polyalphabetic cipher. Along with that, I covered what is auto key cipher. Along with that, I discussed Playfair cipher. Along with that, I discussed the second type of traditional symmetric key cipher, that is substitution cipher. In that, I discussed keyless transposition cipher. So these are the topic I have covered in my last session of this unit. But in my today's session, at the beginning, I'm going to deal with the difference between substitution and transposition cipher and what is stream cipher. So dear student, at the beginning, I'm going to have transposition technique. Once again, here I'm having row column transposition. In my previous session, I discussed what is transposition. So, I'm going to reorder the arrangement. So, there I'm going to consider row representation as well as column representation. For example, think that if I'm having row column, and I'm having the plain text attack, then what I'm going to do, I'm going to create a table and I'm going to write row wise, that is ATTECK, and while reading I'm going to read column wise, that is AACTTK. So this is row wise I'm going to write and column wise I'm going to read. And if I'm having column to row representation, then once again I'm going to draw the table and I'm going to write column wise. So TTCK. Now what I want to do, I want to read row wise. So I'll read ATCTAK. So this is my column to row transposition, but whereas this is my row to column transposition. Now I'm going to represent, that is in the form of table. So that is in the form of matrix. So here if I consider my name Revati, okay, so here I'm having total 7 letters. To make it pair, I'm going to add dummy letter. Now, in the row column transposition, I'm not going to consider any key. And I'm going to draw the table. So here I'm going to draw 2 cross 4. That means 2 rows and 4 columns. And I'm going to write REVATHY and X. Now, I want to read column wise. How I have written row wise, but how I want to read, that is column wise. So, RTEVYAX. That's nothing but RTEVYAX. VYAX, because to represent ciphertext, I'm going to use the capital letter. Now, if I consider this example, I'm going to have Vidhyaashram temple, and they have mentioned that I want to use 7 columns and 3 rows. Okay, I want to use 7 columns and 3 rows. So what I did, I created 7 column as well as 3 rows, and I started with Vidhyaashram temple. Okay, after that there is 3 more fields are empty. So what I'm going to do, I'm going to fill these fields with the dummy letter or bogus letter. And while reading, how I'm going to read, I'm going to read VSMIHPDRLHAEYYMXAEX. That means I'm going to read column by column. How I'm going to write? I'm going to write row by row, and while reading, I'm going to read column by column. And this kind of transposition is called row column transposition. Now, I'm going to have another type of transposition technique, that is keyed transposition. So here, as the name itself indicates, that we are going to have a pair of keys. Based on this pair of keys, I'm going to read the character. But while writing the character, I'm going to write the character as it is. I'm going to write the character as it is. But while reading, I'm going to consider the key. So while reading, I'm going to consider the key. So here they have mentioned that I can able to consider only 5 characters at a time. So what I want to do, I want to consider 5 characters at a time. So I want to consider 5 characters at a time. So what I will do, I'm going to create a table and I'm going to write the index. So I'm going to write the index 1, 2, 3, 4, 5. After the completion of 5th index, once again I'm going to start with first index 1, 2, 3, 4, 5. After the completion of 5th index, once again I'm going to start from 1, 2, 3, 4, 5. After the completion of 5th index, once again I'm going to start from 1, 2, 3, 4, 5. Now what I'm going to do, I'm going to write the plain text as it is, that is enemy attack tonight. And at the end, what I'm going to do, I'm going to place a dummy character. I'm going to place a dummy character, because here I'm having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19. So I'm having 19 character. But if I divide 19 by 5, I'm going to get some fraction value. But I cannot able to consider that. For that reason, I'm going to add one dummy character or one filter character at the end of the given plain text. So I'm going to place X at the end of the plain text. Now, while writing, I want to consider the key. So I want to consider the key. See here 3. So I want to consider the position 3. Okay, and what is present at the position 3? Where I want to write? I want to write at the position 1. So 3, I'm going to write E. Now at the position 1, I'm going to have E. And where I want to write? I want to write at the position 2. Now, if I consider 4th position, okay, so at the 4th position, I'm having M, and what I want to write, where I want to write at the position 3. So, where I'm going to write at the position 3, I'm going to write M. Now, if I consider 5th position, what is present at the fifth position, it is Y. And where I want to write at the fourth location. And if I consider second location, what is there at the second location? It is N. And where I want to write at the location 5. So I'm going to get EEMYN. Now I'm going to have the difference between substitution and transposition cipher. So here I'm going to have the difference between substitution as well as transposition cipher. So at the beginning, I'm going to have first difference in terms of algorithm. So here each character is replaced with other character, number and symbol. That means if I consider this substitution cipher technique, each character is replaced by another character or substituted by another character or another symbol or another digit. But if I consider transposition cipher technique, each character is positioned differently. That means I'm going to just reorder or rearrange the position of the character. Now, if I consider the different forms of algorithm, see here, under substitution cipher technique, I'm going to have monoalphabetic substitution as well as polyalphabetic substitution. And if I consider transposition cipher technique, I'm going to have keyless transposition technique as well as keyed transposition cipher technique. And if I consider the change with respect to substitution cipher technique, here the character identity is changed but the position remains as it is. That means in substitution cipher technique, the character identity is going to change but the position of the character remains as it is. But if I consider transposition cipher technique, the character position is going to change but the identity of the character remains same. And if I consider next difference with respect to detection in substitution cipher technique is a letter less frequently used can be easily traced. That means if I consider English language and here some of the letters are less frequently used and that kind of letters are traced very easily. And if I consider transposition cipher technique, a letter near to original position, so the letter which is nearer to the original position can be get traced so easily. Now if I consider the example for substitution cipher technique, I'm going to have Caesar cipher. I'm going to have Caesar cipher, or I'm going to have multiplicative cipher or affine cipher. And if I consider transposition cipher technique, then the example for transposition cipher techniques are Riemann cipher or row column cipher, etc. These are the example for transposition cipher technique, and these are the certain difference between substitution cipher as well as transposition cipher. And from the examination point of view, this is also very important topic. Now I'm going to have stream cipher. That means the traditional symmetric key cipher is further once again classified into two types, that are stream cipher and block cipher. So what is this stream cipher? So a stream cipher is a method of encryption text to produce ciphertext in which cryptographic key and algorithm are applied to each binary digit. So dear student, please make a note here that if I go with substitution cipher or transposition cipher, there I'm going to consider the character as well as digit as well as special symbols. So especially we are going to consider only character. But if I go with stream cipher, here I'm going to consider only binary digit. So here I'm going to consider only binary digit. So one bit at a time. So stream means what? I'm having group of binary digit. In that I'm going to consider only one bit at a time. So here stream cipher is nothing but the binary digit in data stream. That means whatever the plain text we are going to provide to an encryption algorithm, that is in the form of binary digit, and we are going to consider one bit at a time. So one bit at a time. A stream cipher is an encryption algorithm that uses a symmetric key to encrypt and symmetric key to decrypt. So dear student, once again in stream cipher, we are going to have encryption algorithm as well as decryption algorithm. Perform encryption algorithm, we are going to use symmetric key. That means single key is shared between both sender as well as receiver. And what kind of key? It is private key. Now, this is the example diagram for stream cipher. So in stream cipher, 1 byte. So what is 1 byte? 1 byte is nothing but 8 bits. Okay, in stream cipher, we can able to encrypt only 1 byte at a time. So we can able to encrypt 1 byte at a time, while in block cipher, we can able to encrypt 128 bits. We can able to encrypt 128 bits in block cipher. But in stream cipher, we can able to encrypt only 1 byte at a time. So this is the diagram used to illustrate stream cipher. So here we are going to have the plain text. Okay, for that we are going to have the key and we are going to perform XOR operation. After performing XOR operation with key as well as plain text, I'm going to get the cipher text. Now this cipher text is sent to the receiver. At the receiver side, we are going to apply decryption algorithm along with the key. So we are having ciphertext with decryption algorithm plus key, and I'm going to perform XOR operation. After performing XOR operation, I'm going to get the plain text. So at the sender side, I'm going to use encryption algorithm plus key, and I'm going to perform XOR operation. But here I'm having ciphertext decryption with key, and I'm going to perform XOR operation in order to get plain text. This is the way the stream cipher is going to work. Now see here, initially a key K will be supplied as input to pseudo random bit generator. So what is this pseudo random bit generator? That is nothing but XOR operation. For the XOR operation, we are going to provide encryption algorithm with the key plus plain text. So after that, we are going to get the cipher text. Okay, so pseudo random bit generator, and then it produces a random 8-bit output. So what is this random 8-bit output? That is nothing but the cipher text. So the result key stream will be the size of 1 byte. If I consider stream cipher, we can able to have only 1 byte. So that is nothing but 8 bits. Now, how this encryption algorithm is going to work at the sender side. So here the plain text and key stream produces ciphertext. As we know that when we apply encryption algorithm, what's the input? We are having plain text, then perform XOR operation with encryption plus key. So I'm going to get cipher text. So the plain text will undergoes XOR operation with key stream bit by bit. So here I'm going to consider only one bit at a time. So here XOR operation is going to undergo with bitwise bit. That means the plain text will undergo with XOR operation with key stream bitwise bit. So I'm going to consider one bit at a time to produce ciphertext. Now I'm having the example. To solve this example, I must know XOR table, that is XOR gate truth table. So I'm having input A, input B and output. Okay, I'll write it output. So what are the possible input I'm having? 0, 0, 0, 1, 1, 0, 1, 1. Now when my both the inputs are low, output is 0. And when my any one of the input is high, output is high. Here also output is high. Here both the outputs are high. So my output is 0. Here my both the inputs are high. So my output is 0. So this is the XOR gate truth table. Now while solving this example, I want to consider or I want to remember this truth table. See here, you have the plain text and what's the length? It is 1 byte, that's nothing but 8 bit. So here once again I'm going to have the key stream. What is the length of the key stream? 1 byte, that is nothing but 8 bit. Now I want to perform XOR operation bitwise. So here I'm going to consider first bit. So here I'm having 1 XORed with 1. What is the output? I'm going to get 0. See here, if I consider next bit 1 XORed with 0, I'm going to get the output high. Now I'm having 0 and 0. Okay, when I perform XOR operation, I'm going to get the output 0. And here I'm having 1 XORed with 0. I'm going to get high output. Now here I'm going to have 1 XORed with 0. I'm going to get 1. Now 0, 0. I'm going to get 0. 1, 0. I'm going to get 1. And 1, 1. I'm going to get 0. And this is my ciphertext. And this text is sent to the receiver. And at the receiving side, receiver is going to apply decryption algorithm along with key. So ciphertext and key stream gives the original plain text. So the ciphertext will be undergoes XOR operation with key stream bit by bit and produces the actual plain text. Now the receiver is going to receive ciphertext along with the key. Now the receiver want to perform XOR operation bit by bit. So here to perform XOR operation, I must want to remember XOR gate truth table. So 1, 0, it is 1. 1, 1, 0. So 0, 0, it is 0. 1, 0, 1. 1, 0, 1. 0, 0, it's 0. 1, 1, it is 0. And 0, 1, it is 1. So the decryption is just reverse process of encryption. So here decryption is nothing but the reverse process of encryption. And if I consider previous slide, see here. So what is the plain text I'm having? 1, 0, 0, 1, 1, 0, 0. So it is nothing but 9 and 9. and if I move here, see here, I'm going to get 1001, 1001. It is nothing but 999. Okay. So this is the way we can able to perform encryption as well as decryption in stream cipher. Now I'm going to have block cipher. So dear student, please remember one thing here, that if I go with block cipher, then I can able to have 128 bits. So a block cipher takes block of plain text bits and generates block of ciphertext bits, and both are generally have same size. That means if my plain text is of size 28 bits, then my ciphertext is also of size 128 bits. So the size of the block is fixed. So here the size of the block is fixed. Either it may be 128 or 194 or 256. But the most commonly used block cipher is 128 bits. So the choice of the block size does not directly affect the strength of encryption scheme. So here, whatever the block size I'm going to choose or select, that does not affect to the strength of encryption scheme. So the strength of cipher depends on the key length. So here, if I consider block cipher, the very important thing here is key length. So I must want to select large key length in order to provide security. So while selecting key length, what are the things we need to follow? That is, avoid very small block of size. That means while selecting key, I want to avoid small block key size, and do not have very large block size. That means I cannot able to consider very large block size as my key length. Even I want to consider key length which is always multiple of 8 bits. So I can able to consider 8. It is multiple of 8, 16, 32, before that 24, then 56, 64. Okay, like that I want to consider. Like that I want to consider. That means whatever the key size I'm going to select, that must be multiple of 8 bits. Now I'm going to have the block cipher diagram. That is, I'm going to have the plain text, that is nothing but the block of plain text. Then I'm going to apply encryption algorithm with the key. After applying encryption algorithm, I'm going to get the ciphertext. Now I'm going to have the difference between block cipher as well as stream cipher. So dear student, if I consider block cipher converts the plain text into ciphertext by taking block. So I'm going to consider one block at a time. If I consider stream cipher, I can able to consider only one byte at a time. That's nothing but 8 bits at a time. 8 bits at a time. Even if I go with block cipher, I can able to use 64 bits or more than 64 bits. But if I consider stream cipher, maximum I can able to have here is only 8 bits. Now, if I check the complexity of block cipher, then it is very simple. That means very easy cryptographic algorithm. And if I consider stream cipher, it is more complex because here I'm going to deal with binary bits. Now, in block cipher, reverse encrypted text is hard. That means in block cipher, it is very difficult to perform reverse encryption. And in stream cipher, reverse encryption text is very easy. Now, another difference here is, here we can able to use that is electronic code book algorithm, as well as cipher blockchaining algorithm. That means I can able to use ECB as well as CBC under block cipher. And if I consider stream cipher, I can able to use CFB, that is cipher feedback block and output feedback block. Okay, now if I go with block cipher, it works on transposition technique. So here block cipher is going to work based on rail fence or columnar transposition, etc. So it is mainly going to deal with transposition technique. And if I go with stream cipher, it's mainly going to deal with substitution ciphers like Caesar cipher or polygram substitution cipher, etc. Now, the block cipher is very slow compared to stream cipher. And if I consider stream cipher, it is faster when it is compared with block cipher. These are the certain difference between block cipher as well as stream cipher. And from the examination point of view, this is also very important topic. So dear student, in my today's session, I started with row column transposition. Along with that, I discussed difference between substitution cipher as well as transposition cipher. Along with that, I started with what is stream cipher, how it's going to work. Along with that, I discussed block cipher. Along with that, I discussed difference between stream cipher as well as block cipher. And from the examination point of view, all these topics are very important. And in my next session, I'm going to deal with data encryption standard, that is DES. So here DES as well as AES are example for traditional symmetric key encryption. So the general structure of DES, along with that the data encryption standard, that is initial as well as final permutation, as well as how to generate key, as well as how to apply round function. All these things I'm going to discuss in my next session. And dear student, from the examination point of view, this is also very important topic. So don't forget to watch this topic. Dear student, let's meet in the next session with data encryption standard. Until then, keep watching and keep learning. Thank you.